In this video I'm going to talk about MSTs again, and this time I'm going to use Prim's algorithm to find the shortest path. In Prim's algorithm we're going to have a priority queue that we store our edges and weights in it, and we're going to have a visited list that is going to keep all of the all of the vertices that we visit. Okay, this visited list is going to help us to avoid any cycles in our graph. Okay, so let's get started with this graph and find the MST. First of all, we need to have a starting node. So let's say that we start from node V1. Okay, so when we look at V1, we can put V1 into our visited list, and we're gonna add all of V1's neighbors, which are here, to our priority queue. Okay, then the next step is to take the next smallest edge out of this priority queue. So V1, V4, which is this guy here, is going to be the element that we take out, and we first check to see if V1 and V4 are already visited. So we check it with the visited list. V1 is visited, V4 is not, so that's a valid case to take out of the priority queue. So we add V4 to our visited list. We're gonna mark that edge V1, V4 in here as visited, and we're gonna also add all of V1 V4's neighbor to our priority queue. So we're gonna say that this list is added to our priority queue, and also these two are added to our priority queue. Now the next smallest element that we take out of here is going to be v4 v1 with the weight 1, and v4 v1 has been already visited, so we're not going to consider this one. We go to the next smallest, which is going to be v1 v2. v1 is already visited, but v2 has not been already visited, so we're going to add v1 v2 to our MST, which is going to be this edge right here, and we're adding all of v2's neighbor to our priority queue, and also of course we are adding v2 itself to our visited list. So let me add all of the v2's neighbor to this priority queue here. Now the next step is going to be taking the next smallest element out of the priority queue, which is going to be v4 v3 with a weight 2. v4 is already visited, v3 is not visited, and we can add that edge to our MST. So v3 is going to go to the visited list. The edge v3 v4, which is right here, is going to be marked as visited in our graph, and we're going to take all of the v3's neighbor and put it in our priority queue. So we're going to have the priority queue to look like that, and the next smallest element that we can take out of this priority queue is going to be v1 v2 with the weight 2. So when we take v1 v2 with the weight 2, we compare it against the things that we have in the visited list. v1 and v2 are already visited, so we're not going to consider that edge. We go to the next smallest edge, which is going to be v3 v4. v4 is already visited, and v3 is already visited, so we're not going to consider that edge. We go to the next smallest one, which is going to be v4 v2, but v2 and v4 are already visited, and that tells us that it's going to make a cycle. And when we look at the graph here, we see that v4 v2 indeed is going to give us a cycle in our MST, so we're not going to consider that one. We go for the next smallest one, which is going to be v1 v3 with the weight 4. So v1 v3 with the weight 4 is going to be right here, but as you see, it's going to make a cycle. Now let's consider the visited list and see if that visited list is going to tell us the same thing. So v1 v3 are already visited. There you go. So that's why you can't add it to our MST. We go to the next smallest one, which is going to be v2 v4. Actually, we should have visited this one first, but as you see, v2 v4 is already visited, so we don't consider that one. Then we go to v3 v1, which is again going to be the same case as here. We go to the next smallest, which is going to be v4, v7. v4 is already visited, but v7 is not. So we're going to add v7 to our visited list, and we are adding the v7's neighbor to our priority queue. So v7's neighbor are going to go to priority queue, and we make this line here from v4 to v7, and show you that we have visited this one. Then we go to the next smallest element in our priority queue, which is going to be v7, v6. v7 is already visited, but v7 has not been visited, so we can add, v6 has not been already visited, so we can add v6 to our visited list, and we add all of v6 neighbor to our priority queue, which is going to be right here, and we mark that edge as visited. So let me mark that edge as visited, and we take the next smallest element out of here. So v6, v7 has been visited, so we're not gonna do anything with that, and we move on to the next smallest edge that we can see. So the next smallest edge is going to be v7, v4, and as you see, v7, v4 is already visited, so we're not gonna add that to our MST anymore. And we go to the next smallest, which is going to be v3, v6. v3, v6 is going to be right here, and as you see, it's going to make a huge cycle here. According to our visitor list, we shouldn't be able to add that. So let's just confirm. So we're talking about v3, v6. So v3 is right here, v6 is right here. So they're both visited. So we're not gonna add that edge to our graph, to our MSD. Okay. The next thing that we do is to get the next smallest element, which is going to be v3, v6 with a weight 5. v3, v6 with a weight 5 is again the same problem, and we move on to the next smallest element, which is going to be v7, v5 with the weight 6. So v7, v5 with the weight 6 is right here, and we should be able to add that, and let's confirm. So v7 is here, v5 is not in our visitor list, so we add v5 to our visitor list, and we add all of the 5's neighbor to our priority queue. Okay, now we mark also this one as visited. We mark this one as visited, and we're pretty much done, because our visited list now contains all of the verses that we have in our graph: v1, v2, v3, v4, v5, v6, v7, and that's telling us that we are done with our algorithm. You could also continue pulling stuff from your priority queue and see if they have been already visited, but it's gonna take a little bit longer to do that. So you can easily check that if the visited list contains all of the nodes in a graph, then you're gonna declare that you are done with your MST, and that's how you do prims to find MST.